contiguous subarray within a one-dimensional array of numbers which has the largest sum. Okay, so we need to find the sum. So we need to know the sum. We don't need to find the indices. Okay. And let me draw an example and work from there. Okay. It looks to me that the brute force way is to find every possible subarray and its sum and compare it with a maximum. And if it's bigger than maximum, then we update it. And the time complexity is O of n squared, because we are doing one loop and then another loop and then another loop. We're going to run n loops, so it's n squared. So how can we solve it in linear time? I'm going to clean this up. Okay. So how do we solve it? Like in linear time, then once we look at a number, when we pass through it, we should not leave nothing with us. We should at least remember something. And what we remember will help us find the answer. So we need to find the maximum sum. That means we need to remember the current sum. Yeah. So okay, let's try to remember the current sum. So -2, we can try to remember it here. So this is current sum. -2's current sum is just itself. And next 3's current sum. Should we add the -2? No, because it's negative and will hurt the sum. So it's 3. So what we just did is if the previous current sum is less than 0, we do nothing, and we just update the current sum to be the element itself. Remember remember itself. Okay. And then we go to 10. Should we add 3 to 10? Yes. Should we add 7? Should we add 13 to -7? It sounds weird, but yes, because we want to continue this subarray to look until the end. We have a big number here. If we stop here, then we cannot find 100 later. So we're going to add this up, and the current sum becomes 6. And should we add 6 to -8? Yes, -2. So we mean if previous sum is larger than 0, we add it to current element. Okay, now it's -2. So we should not add it to 100. We just remember itself. It means the 100 itself. Okay, so now we have the whole array of current sum. It's very obvious that this is a max. So to find the max, we should keep a variable, something like the max sum. Yeah. And we have to update it and to compare it with the current sum every time we have a new current sum. And if it is bigger than the max sum, we should update the max sum. Okay, so now we can write some code, I think. Oh, wait a minute. So we don't want to all of n space because we only need to remember one thing every time. That is a current sum. And that could be just a variable. Yeah, because for example, to know if we need to add 6 to -8, we only need to know 6. We don't need to know any of this. So we can, instead of the array, we can just keep one variable, one container here and update it. Yeah. Okay. Now let's write some code. And by the way, the time complexity is O of n. We solve this problem by one loop. And the space complexity is O of 1 because we just use variables, no extra space. It's constant space, yeah. Because we only have to have 2 variables space. Okay, now let's write the code in Python. MaxSubArray. Current sum is, let me just check some corner case here. If nums, if the length of nums is 0, that means we don't have any subarray. So should we return 0 or none? I think it's better be a number, so let's return 0. And if the length of nums equals 1, we just return the the only element. Else, so that is we run a for loop for I in range 1 to this nums. If current sum is less than 0, okay, we need to initialize the current sum. So initially it is nums 0, and the next sum is initially the current sum. If current sum is less than 0, then we should remember itself. Okay, so we remember things in this current sum variable, and itself just means the element itself. So nums I, the current element. And if the previous sum is larger than 0, then we add it to current element. Yeah, so else current sum is current sum plus nums I. Okay, and we should compare the max. So max sum, if max sum is smaller than current sum, max sum equals current sum, return max sum. Okay, that's it. Thank you for watching. Bye bye.